steps, for instance, in steps, load data, import, what's it called? Yeah, load data. Okay, we can just change this to ingest data. So it's a little bit right. Let's see ingest data. So from we can see from ZenML data import, ingest data. All right. So we can so from ZenML train model, ZenML train model, we're importing train model. Right. So we can start our pipeline by saying, okay, pipeline, sorry, pipeline, not pipelines. So we'll say simple ML pipeline, because that's what it is. Very simple. Then create a model name, pass model name to it. A string. That's what we're getting from developer. Right. Then we say data sets equals to load, sorry, ingest data. Right. So ingest data is gonna return a pandas data frame. Then we're gonna say the model would equals to train model, this data sets, right? And then the model name, right? Right. So we can end it there. So, but we would also need to create a a script that just runs this pipeline outside of it. So we can just call this say run pipeline dot py. Right. So it should appear here. So in our run pipeline dot py, we're going to be performing some magic. So we say from pipelines. So we have to also touch this in here. Pipelines. Oh yeah. All right. So we'll be able to interact, but it's just like a field measure from, I guess, from pipelines, training pipeline imports. So is this is what ZenML will call your pipeline, and this is what will automatically go to MLflow as your experiment tracker name, right? So we return this here. Then because we'll be passing some arguments to our runs, we have to import click. Click help us do that. And from we need to get our tracking URI, right? ZenML. That is where when we go to this URL, my tongue. When we go to this link, we'll be able to actually interact with the experiments that have been tracked in MLflow, right? So let's do that with integrations with the MLflow because that's how we integrate it. MLflow to import get tracking URI, right? So tracking URI. So the options there would be linear regression, decision trees, random forests. Sorry, random forest. So I'm gonna pass the notes. Click options. So click options. Um, So we'll call this linear regression. That's the name of the person. So it would be decision tree instead of camel case. Um, then this would be random forest. Yeah. So that's what it's gonna be. And there are a lot of things that I need to put here, and I'm feeling quite lazy, so I'll just go copy, get in and paste, and then explain. Okay, so I just pasted here. um, Let me make a quick correction. Okay, so essentially, we're initiating our click command here. It's gonna draw one single parameter option, which is our model name. It can either be this, you can actually call it this, or with the double dash, or just say dash m. So the choices are going to be these three options, right? Then our pipeline result is going to be, oh, we don't really need a pipeline result. That's when it's finished, right? But yeah, we pass this pipeline we've imported from our training pipeline, which we just created here, right? We pass it, then don't really need all of this yet, right? I don't need this too. This was for when I was testing, right? So we pass the and when you click on the link returned by the URI, you'll be able to interact with every experiment tracked, every single run, and the set experiment name, which I call memo for example pipeline here, right? So that's it. If we were to run this, I hope we don't get some errors. But hey, yeah, get comfortable with errors anyways. So let's see what we have in our directories here. Okay, we have the run pipeline. So let me say Python run pipeline, for instance, the py, and then we'll pass a linear regression as a model name. Should expect this to run. Let's see. Spent about half an hour now. Thanks for being with me. If you're still here, thanks for being with me. This is my first ever screencast sort of thing. And so if you're still here, thanks. Um, so yes, this is our first run. Let's see what happens. Okay, it might be taking a while because this is the first time we're running our pipeline, and maybe this is what is taking the time going to fetch this. But okay, let's wait and see. Okay, so I can see we've got some errors. Let's see. Uh, so in our training pipeline, it's taking out lots of train model. Okay, so I made a few changes and ran it again, but still got this error. It's experiment tracker. So I think I need to add this here. All right, that should get the name of the experiment tracker. Let's try again. Fingers crossed. Oh, nice. So you can see we're initiating a new run for the pipeline. It fetches that name from our training pipeline called Simple ML pipeline. Alright. So as you can see, it's registering a new pipeline, executing a new run. The username is default. It's storing our stack in our MLOP stack. Right. So you can remember the name of our artifact store. Orchestrator is default. Experiment tracker is this. You can see how nice and smooth ZenML can be. So caching enabled explicitly for ingest data. No, no, so let me just read out everything verbatim, but I cannot just be, you know, contain my excitement. The first time I used ZenML, I thought I saw Jesus Christ, it was just so smooth. It was what I expected, and more. So as you can see, it has successfully trained, successfully ingested the data set, successfully trained, right? Ingested data, successfully trained a linear regression model and stored that model to a local model register right here with this name, right? So that means when you can see right here, we've created a model registry that stores. Is not amazing? Right? And it has also created a local data set directory, right? So now, having trained the data sets, yeah, let's finish this up. So blah 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 blah. When we run this, we'll be able to expose our MLflow library, sorry, UI, and then interact with the experiment struct. So let's see. This is our tracking URI, right? So it's starting. And while this runs, you can also do this. You can also do send ML up. If you're on Windows, you have to add blocking. It just shows how amazing things can be. So I just did, but let's do it again. So this will return this local link here. So when you click on it, it takes you to your MLflow UI. You can see the name of the experiment, right? Simple ML, right? You can see the run name when it was created about 20 seconds ago, around just 19.8 seconds. Although the data set in this case is relatively small, but it's just amazing. So let's look at this. Let's look at the metrics retrieved. Our RMS score is 63, 6,311 point something something. Right. Store the model name. Also register the model. Right. So you can see the run ID from here, the experiment ID, the model metrics. Okay, because we have just one, you can only see a single chart here. The 6,300 something. So you can see the artifacts here. The data is stored in our local stores, which we created initially. Right? It's just amazing. So you can also see that the model is registered right here. The model itself is given this tag, stage to prod, regression model, right? But when we open this, you can see version 1, our first version. We call this staging. So it's still in staging. We've not pushed this to prod or archived it based on any logic, right? So you can imagine that we'll be running many versions of this model right here. And when we'll be choosing different model names, we should be seeing different RMSE values. Then we can now say, okay, if we get an RMSE value of this right here, and we get a lower RMSE, say in the 31st version, can we also promote that 31st version from staging to production and archive this particular version? So that is the next step now. We're going to write a promotion logic that is going to go into our module registry, fetch the current uh, version, right? If it's the first version, it automatically promotes it to production. If it's already in production, fetch it and check it against what we currently have in our training model. So we'll be doing that with promotion logic right here. All right. So we can just okay. Yeah. I wanted to show you guys how to check out ZenML. So let's see what that looks like. So your default name is default. You log in, right? So you access for some item, blah blah blah. Right, right. I will continue. Reason for personal. Yeah, what are we doing? A plan proof of concept, or the or we're working locally, right? Or we can just skip this step. So you can also go ahead and join their Slack, right? Skip. So when you come to pipelines over here, see our pipeline, right? And you can see, right? You can see it's just two major steps at the moment. Our noted values are also showing up here, where we ingest the data. You can also see the code. It's just amazing. And then the train model, right? You can see the stack right here, right? You can see the code. You can see what's logged, right? Right. It's just amazing, man. So let's just continue because this is sweet work. Now let's close this. Right. Um, the next thing we're doing is we're going to write the logic from the model. Like before, I don't want to spend time writing all the code again. I already have it somewhere, so I'll just bring in that logic in here. Okay, so so first, I realized that we actually need a fetch tag script. This is a script would get a MLflow client and essentially go through our models, our registered models based on the assigned tags, right? So once it gets that tags, it tells us the version, the tag, the run ID, and the staged value, right? Then it tries to get the latest version, the version assigned to the latest model, right? Returns the RMSE value as a float object. So that just means that it comes out as a neat in like decimal form, right? And returns the path where the model is stored, just like we saw in our artifact directory. So he also logs that he's completed this, and then if not, it tells us it can't find any model with that tag, right? So this like the the major um how do I say this? Like what drives the actual production logic, or it's one of the things that actually makes the promotion logic work. Being able to go into registers and fetch things by files. So we're going to import that get model tag function from our fetch tag script. All right. Then it starts. So the first thing we do is we uh, okay, yeah. The first thing we do is we retrieve the model from this step. The ZenML object, model object from this step. I don't know why it's showing that. Okay. So it retrieves that, then it sets MLflow tracking URI to the URI. I think there's a better way of doing this where we just store the URI in a .m file. So we'll do that. But let's go ahead. Our MLflow client is going to be our MLflow client. Then it's going to retrieve the name of this model object, which is assigned here. Right. Then that key is going to be staging. This is the key we're going to be looking for, right? So we say get the model by tag, return the model object, the staging RMS value, and the staging version, right? So it logs this as it carries out those things. However, there are times where, or the first time you run your training pipeline, you shouldn't have any model already in your model register. So what you're training is the first one. So how do we handle promotion in that case? What we do is we set our promotion RMSE value to a ridiculously high positive value, because we know that the lower the RMSE value, the better the model. So we set this to an infinite positive value. So our train model should return an RMSE value lower than this, right? So it tries to get, like I said, the first time around, it tries to get the production model by the tag production, which isn't there because it's the first time we're running it. If if it finds this out, then fetch the RMSE value, right? Then if our staging RMSE, which is what we've just trained now, is lower than the production RMSE value, simply change production to archive, uh, delete the tag first, then set the new tag to archived. Now in our staging RMSE, change staging version, um, delete the staging tag, and then set it to production. So it becomes our new production where the previous production is archived. So it returns this statement that it's promoted staging model to production, archive previous production model, right? So if not, it simply deletes the staging and reassigns it to archived, right? So if we can't find any previous production model, right, so all we just do is we simply just pass the staging directly to production. So okay, that means there's no need for this right here, right? So if it doesn't find a previous production model and it's the first model we're training, just auto promote it from staging to production. So what will happen is we never really have a staging model saved or registered in our model. What we just see is production or archive, right? So it deletes that model, same logic, and it reassigns it to production. So the yeah, I've mentioned that a lot of things form the foundation of a production promotion logic, but this particular argument from MLflow model registry, which is in their documentation, very fantastic documentation. I think if I can find it here, okay, it's not. All right, so it's I'm going to put it in the description. It's how we're able to manage tags. You can also do the same thing with aliases, and I think you can also do the same thing with environments. But because this is my first time trying things out, I sort of saw how easy it was to just use tags, right? So uh, yeah, it returns, it attempts it, then once it's completed, it completes it. And if there's also an error in doing this, it just returns an error, auto promoting, you know. And then we want to pass a final output where we want to know if indeed promotion worked or it didn't. So in a case where production model, staging model is worse than what is already in production, right? We return it false. That means production didn't work, and otherwise we say it's true, right? So that's how this works. So what we can do, we go into training pipeline, and then we say is promoted, right? Equals to, okay, we have to import it. So from steps, promote model, promote model, import, promote model. Okay, that's why it's also called. Say import promote model, right? So we say promote model. All we need is a single argument of the model, right? It only takes one thing. So yeah, we're gonna try. Then close this. Then you can say return is promoted. Right? right? So that's how we do it. What else? So in our training pipeline, yeah, you can just run the same thing. You can just run the same thing. I'm trying to see if I'm missing out. Yeah, let's just go. If we ever hit an error, we'll review it. So let's see how it goes. Let's see how it goes. Wow, you spent 55 minutes, almost an hour now, right? Yeah. So it's initiating a new run, right? This default values that have been set, return, we're training the model now. It takes some time because we're not caching, right? So we created version 2. Nice. So if you remember when we looked at model registry right here, when we looked at model registry, you could see that it really has staging. So that's why we got this error here that I couldn't find the previous production model. No model found the production tag. If we were to run this again, um, let's say now we say instead of linear regression, we use a decision tree, right? Which I think will actually be retrieve better RMSD value than this 606,000 value. We should be able to dethrone the current production model. So we wouldn't get this error anymore. And we should see that you can see the staging model was automatically promoted to production, right? And it finished in just about a second, right? So this is also taking some time. See how it goes. Wow, that was fast. So now we've created the production tag again, another version, right? So this was what was currently there, version 2, a 631 value from here, right? From here. And now we've fetched that model, completed the fetch. Now we compared it to what we currently have in staging, which returns 6302, which is lower than 6311, right? And because of that, we've routed this as staging model to production and archive this previous, this previous model right here. So you can just see how beautifully ZenML does things. The logs are just, I don't know, um, you would think all the best, all the goodies are stored in the cloud, but here's a fantastic example of how you can orchestrate an entire machine learning lifecycle on your local machine, on a Windows local machine, right? So when we go back to the registry here, you can see this has been archived now. The first one was just placed in staging because we're experimenting. This has been archived now, and then the new production model version 3 with the RMS score here, right here, right, stored as a value. So we don't stop here. What we just need to do next is to let's go back to our README. We've done this, right? So we can, okay, maybe I'll just leave it. The last thing now is to create a user interface with Streamlit. So So you can just close this. We are done with the steps, pipeline, and local directory. So the local steps creates a directory for every action, right? So, oh, local stores. Oh, okay. I don't know why, but hey, okay. Yeah, something was supposed to not work here. The MLflow tracking URI worked. Okay, so there's no need for an environment here. So next thing we do using git bash, can just create a script for our Streamlit app. By the way, if you stuck with me till now, you're the MVP. Thanks for sticking around. And while we build stuff and we eat errors, we bounce from the errors, and we make things happen for ourselves, right? So okay, so we want to import Streamlit as ST, right? Where else? We need need to import MLflow client from MLflow client. So mistake from MLflow client import MLflow client. What else are we importing? So I think we need to import a tag from steps dot tag import get model by tag, right? So we're building a very simple interface that um, fetches production model artifacts. All right. And a user input widgets and then production prediction, right? Prediction, very simple, right? Prediction, right? What else are we doing? Yes, we'll be enabling caching one some stages. Right, so these are the three major things we're doing. All right. So there's a few missing things. Import MLflow. We also need to import pickle. I'll show you why. And pandas. Import as PD. All right. So okay. So first one to enable caching. So our app doesn't. It just helps with the runtime of the app. So we say on the cache resources. Not sure I'm doing this right, but yeah. But I know you can work with. I think it may need to pass some parameters to that, but let's just go. Uh, so let's say yeah. So from here, return this. We want this. No, why this one that time? Let me just assume it will work again. I'm not sure why it works. Let's import OS. Alright, let's go. Let's go. Let's go. Let's go. Let's go. Um, a model name. What do we call a model name in our train models? The model name is this. So we're saying try just the same way we got uh, values from here. Let's copy this. Let's paste it here and change. Let's change everything stage into production. So that we have to production. Let's replace all. Use the tag key is called production really. We don't need to put the key as come here and say production. Okay, that's what we're gonna call it. Right. So what else? We're gonna say we're gonna return a log that says success something successfully. This is just to you can even add the RMS score and say RMSs to this. Okay, if we get an error, say accept exception. E when it just tells us that it wasn't able to find the function model. Again, you have to have logs to know that things work. So if this doesn't work, we fall to the last resort because we always want the customer to, or the user to, the user experience is paramount. So what we do when we can't find it is we simply go into the model directory and fetch. You can just stick to this one, right? Right here. Let's copy the path. Let's try local production model. Uh, let's say that's and then we open a pickle, say open local production model. Open, no, RB stands for that's that's say production model request to pickle dot load file, right? So uh, then we say st dot success, say results, just say so that the customer see that just put one in there. It's called yeah, it's, I think it's something. It's not one in. It's called something. Error. Yes. So yeah, let's just put one. Let's make this one. uh, F of file. Let's call it file. Let's be explicit, right? And once we've done that, we can now check again if there's still an exception. I will give up on exception. So next thing, I'm not sure next thing, try an exception chunks is best practice, but it's worked beautifully for me, you know. So it was no local, no no model in reserves, right? So we just don't have downtime, right? So we can now come out and say production model. So we can just call this function. So right here, we can just give it a title. So we say um, simple. Okay, let's call it salary prediction. Then we say It's just collecting a single attribute, which is work experience, right? This is our widget right here, number, input, work experience. Yeah, so it has to be the same name as what we have it in what we had in our train model. So you can pass some arguments. You can say, for instance, the minimum value is going to be 1 year. Actually, it can be 0 since you may not have experience. The value, current value, when you click on it, is going to be, let's say, 5. Let's say 5. And then the step which you could increase this by, by 1, by 1 year. So let's take that and see what's in predict. Click down. Then once you say if production model is none, which shouldn't. Oh, sorry, it's not none, which it should. Then we say we create a data frame, right? Create a data frame. With the input data, say input data equals input data equals to PD data frame. So we still use our pandas here. We just create a float work experience. Right, we just copy this. So we'll make a prediction. Prediction is just simply not going to be our prediction model predict input data. See how easy, or maybe not so easy now, because when I was doing this, it took me weeks, man, to just figure things out. And one of the reasons is because we don't have so much literature on the topic, which is also cool because then you get to like produce your own literature, your own style, But it really helps, I guess, when you're finally able to figure things out on your own. And I hope I'll be able to do more of this. Right, right. So that's it. That's it. That's it's as simple as it is, right? So let's just make some small adjustments, stuff, right? But that's it. That's it. So what we can do from here is go to here and say Streamlit. Let's see what's in our directory. Let's start in the directory. It's right here. So we can just say Streamlit run up the pie, right? And then it runs. So it's running. For the first time, usually it may take a time or it may take some time, and that's why it's a genius thing these libraries have the ability to cache, right? So as you can see, oh, it's saying no production model found. Interesting. This is interesting. It's loading from our reserves. So let's just pause this and look at why. Because we should find production model. Let's see why. Let's look at the logic right here. Let's see what it is now. And yeah, that's why it should be now. So let's copy this. Let me compare what I have here. It's identical. So why isn't it finding? Let me comment this out. Maybe this is the reason why. Oh, okay, okay. I think I know why. This has to be outside, right? It has to be outside the function, right? So let's try again. So we'll do this. Run. We will run. Let's see. Let's just let's clear cache. Clear cache. Hard refresh. Oh, system no production model found. Wow, it's not able to predict. Okay, okay, okay. All right, let me get this one. Okay, so I had to, pass the that track URI to this to make it work, which is just an intervention thing, but you ought to be able to dynamically pick up this get URI value, change the backward slash to forward slash. Yeah, it worked. So if we were to run this, because it's cached, if we were to do a hard refresh, let's see, I successfully got it from, and it also shows you the current prediction RMSE value. So if we were to predict, we get you get paid 67, about around 68,000. Yeah, so that's it. That brings us to the end of the screencast. It's been a few minutes above an hour. If you spend so much time just listening and following through, man, I really appreciate how you pushing all the code to my GitHub. Please go check it out. Send me comments, send me chats, send me challenges. Let's figure things out together. Um, yeah, thank you.